Now we are starting with the second part of the first problem set. How do we solve this problem? 0 is 4 over y, 11y plus 16. We want to subtract 16 from both sides to make sure that we get only y terms on one side. So we get minus 16 is 4/11 of a y. Now, what property do we use to get rid of 4 over 11? The one that we reviewed in the very beginning of the problem set. We will be multiplying by inverse fraction times 11 over 4. Of course, that means, let me put it like this. We have to do the same multiplication on the left-hand side because they have to stay equal. Now, nice and easy, we have gotten y on the right-hand side. On the left-hand side, we have, I hope you remember how to multiply fractions, 11 over 4 times minus 16 over 1. And now you can either multiply and then divide, or you can remember that 16 is basically 4 times minus 4, negative 16 that is. And now this 4 and this 4 cancel each other out, and all we get is 11 times negative 4 over 1, which is negative 44. Pause it if you need. Go over it again, try to solve it, and I hope you get the same answer. For number 10, we are simplifying. As you can see, this is not an equation. So all we will be doing is distributing and combining like terms. What do we get? 2x minus 10. Now we are distributing by negative numbers, so that will change the sign inside the parentheses. Negative 6x. Negative 6 times negative 1 is positive 6. And we are simplifying. From here, we want to combine like terms. We have 2x minus 6x. The negative x is greater, so it will be negative, and it will be the difference between those two. Negative 4x minus 10 plus 6. I hope you know that that is negative 4. This is our answer for number 10. 11. We are solving for y. What does it mean? We will want to get the final answer. Y is in some kind of expression on the right hand side. All the y's have to stay on the left hand side. So how do we start here? What they gave us is a nice beginning because we do have two terms with y and they are both on the same side. Now, how do we get them out? We will be using something called factoring out. And it's basically like backwards distribution, and you will see why. We divide the first term by y, and all we have left is 2x. Now we are copying the symbol, plus, and what do we get after we divide 7yz by y? 7z. So we have changed our left-hand side, and the right-hand side stays the same for now. And I told you this is basically like distribution backwards. If you have a look at this, you will see that if we do distribute what we have just written, we do get the expression that is in our original equation. And that's important. Not that we need to do it now, but we need to be sure that the original and the formula we have right now are still equal, because their right-hand sides are equal, 9x, so the left-hand sides will have to be equal too. Now, what is the operation that we are using here? I know we have an addition, but that's inside the parentheses. We don't touch that. That's like one big expression. What is the relationship between y and the parentheses? What is the operation we are using? And I hope you all know that it is multiplication. How do we undo multiplication? By dividing. So we will be dividing by 2x plus 7. z. We have to divide the right hand side by the same expression, 2x plus 7z. And our final answer, because this cancels each other out, is gonna be y is 9x divided by 2x plus 7z. I've had people come to this point, which is great, but then they were thinking maybe we can divide the top and the bottom by x. And yes, we could do it if, and this is important, if there was only multiplication on the bottom. But this is not the case. We have addition, and the right term, 7z, does not contain x. So it is not possible. We cannot make it any simpler than it is. This is the final answer. Please pause it for a second and think about it. If that's the mistake you have done, why do you think you cannot get rid of that x? Think about it, please. Okay, and then we have problem 12. And this is absolute value problem. And I hope by now you remember that absolute value, there are only two things, two numbers that have absolute value equal to 11. And that's 11. So absolute value of 11 is 11. And absolute value of negative 11 is 11 as well. And this is the key for solving this problem. So basically we are trying to find an x for which this expression inside the absolute value symbol is either 11 or negative 11. So that's it. 7x plus 3 is 11. Here is this. This is confusing. Or, that's very important, or 7x plus 3 is negative 11. Again, no magic there. Nothing tricky. We know that inside the absolute value symbol, it has to be equal to 11 or minus 11 to give us this answer. So this is how we split it, and now we are solving. We will be subtracting 3 from both sides. 7x is 8. X is 8 over 7. Or, after subtracting 3 here, we get 7x is minus 14, which will give us, after dividing by 7, negative 2. So those are two answers for this problem. Next, last two problems. Again, we are using absolute value, but this time inequality. And again, expression x minus 2, and let me just draw it above here. The absolute value, it means the distance from 0 is greater than 9. There are two numbers whose distance is exactly 9 from 0. That's 9 and negative 9. Because it says greater than, we cannot include the 9, but we will be looking for values that will give us answer further away from 0 than the number 9 and minus 9. So this was just for illustration, and now I will rewrite it algebraically. X minus 7 is greater than 9, and that's this right part. This is it. Or x minus 7 is, and this is very important, less than minus 9. And you will see why. It has to be further away from 0 than minus 9, so it has to be less than negative 9. And now we will start solving. We'll be adding 7. We get x is greater than 16. Or, adding 7, x is less than minus 9 plus 7 is minus 2. So these are our two intervals. And you know when we have this problem, this is OR statement. We are expecting two intervals. I will graph it for you, even though you were not expected to do that. -2, 16. These values are not part of the solution, so the circle is empty. And we'll be going away. Again, the first graph I showed you is the graph for x minus 7. Now this graph is graph for x. And if I did ask you to do interval notation, it would say minus infinity. You know, we start all the way from the left. To -2. 2 is negative 2 is not included, so it will be the soft brackets, union, and then soft parentheses, 16, and all the way to positive infinity. Again, both infinities, they have to always have soft brackets. So we have done 13. We have done even more than we were asked to, but I believe it's a great review. And now let me help you solving the set problem. First of all, this symbol is symbol for a set. Really, you should not be using parentheses if you are describing a set. It is the curly brackets that we are looking for. Second, when we have parentheses in the problem, it is same like with order of operations. We first solve this problem. And let me illustrate it for you. We have set S. We have set V, and now what we are looking for is their intersection. So all the elements, all the numbers that they have in common, that is called intersection. We can also read it as and. So the elements that are in S and also in V. That's it. And there are only two such numbers or elements, and that's -8 and 8. And now we will continue. We will be looking for set T union this answer from the first problem. And union is also OR. So we will be looking for all the elements that appear in one or the other. We will cover them all this time. So T has -5, -3, 0, 3, 5. And besides them, we have to include -8 and 8. Let's start with the lowest number, which is -8, -5, -3, 0, 3, 5, and finally 8. So this is the final answer for problem 14. I hope it helped. Have a wonderful day.